I keep my screen share up.
Actually,
Like,
no. If you drop that so we can see your face. But hello, everyone. um, Welcome to the our virtual jug session. And today's virtual jug session gives us a speaker who's joining us for the first time in Kito Mann. Kito, how are you doing?
good. How are you doing?
I'm very well, thanks. And whereabouts are you calling in from today, Kito?
I'm calling from Richmond, Virginia. It's about an hour and a half south of the DC area.
Oh, wow, cool. And is it cold down there this time of
Yes,
year?
it is. It is. It's one of those areas that gets it's gotten warmer recently. It's a fairly warm area, but it's around 30 degrees Fahrenheit now, and we're expecting like a foot of snow this weekend. So
Oh wow! So that's about what's that? That's about 0 Celsius
yeah,
for the rest of the world.
exactly,
Okay,
exactly.
cool. And Oleg, how about you, man? How are you holding up in the sub-zero Estonian temperatures?
Actually, I'm pretty good. It's getting better now. We get a little bit of sun every now and then, so it's amazing. And just second best thing that I have in my life is a virtual jug, naturally. So today is my lucky
Excellent.
day.
So what's the first out of interest?
Oh, Rebel Labs, of course.
Oh, of course,
My passion and my day work.
of course.
So where are you located, Oleg?
I'm in Estonia. There is a
Ah, okay,
small town called Tartu.
okay.
So Eastern Europe, for those of you who don't know where Estonia is.
It's a beautiful place as well. I very much recommend going there in the summer, for sure. So let's talk about today's session then. We have virtual Java user group session called Modern Web Apps with HTML5 Web Components, Polymer, and Java EE MVC 1.0, which is a very, very interesting new JSR coming up. So it would be great to hear from Kito on this today. If you want to follow Kito Man, which I recommend on Twitter, you can follow at Kito99. And you can hear about some of the things that Kito does, including actually an enterprise podcast, which is very interesting for those of you who do follow the Virtual Jug podcast. Kito and a few people do talk about some of the interesting new frameworks and enterprise-style announcements and releases, and that's very, very interesting as well. The VJug is sponsored by Zero Turnaround and media partner Rebel Labs, which tends to do write-ups and reviews or roundups of every single session. If you wanted to try out JRebel or XRebel, you can do so at zeroturnaround.com, where you can download some free trials and update your Java code and view your potential production-style problems during development very, very easily. So today you can interact with us on IRC. You can either go directly to a Freenode server and go to channel #virtualjug, or of course, if you're using the virtualjug.com website, you'll see the IRC widget right next to the YouTube window as well. Please do share the group and session. In fact, as I mentioned last time, we're up to just over 5,000 members now, about 5,200 now, and in fact I put actually a video out talking about how pleased me and Oleg are about that, and just saying thank you to a bunch of people, so do check that out on the Virtual Jug YouTube site. Again, if you have any feedback at all about the session or Virtual Jug, you can contact us at Virtual Jug or myself directly at SJ Maple, so feel free to ping us on that. And so, yeah, without further ado, let's jump straight in, and I'll pass control over to Kito.
Okay, thank you. Let me do my little screen share here and get rid of this stuff. I've got the common too many windows open.
That's the classic when you start hearing huge amounts of noise from one of the windows and you have no idea where it's coming from.
Yep. All right, here we go. Okay. Okay. So thank you for the intro, Simon. So you have the title, right? Modern Web Apps with HTML5 Web Components, Polymer, and Java EE MVC. I'll get into what all of these things are if you're not familiar with some of them in a minute. I'll just tell you a little bit more about myself first. My name's Kito, and I am the principal consultant of a company called Virtua, which I founded. And there we do training, consulting, mentoring, architecture, etc. for a wide range of technologies. The core area focus is our web development with Prime Faces, JSF, Java EE, and now we're also doing stuff with Web Components, Polymer, and LifeRay as well. So those areas. We're also an official Prime Faces partner for the US, so I do a lot of JSF stuff. I wrote a book a long time ago called JSF in Action, totally out of print. I also run a website called JSF Central, which is good for JSF stuff. And as Simon mentioned, I'm the co-host of the Enterprise Java Newscast, where every month or two, me and Daniel Hinojosa and Ian Hlavitz talk about Enterprise Java stuff. Also, we talk about Scala. We talk about new releases, and also we started having guests on. So we actually had Venkat on there recently too, Simon, to talk about all sorts of random language things and things in the world of Java. So you can definitely check that out. It's also on iTunes. I also just started a new site called noesis.io, and there I'll just be, providing more sort of information about web components and other technologies going forward. So it's just another stopping point for places to find out more. I speak at lots of conferences, and I'm a member of the Java community process. And I've been involved with a few different expert groups, JSF, the Portlet expert groups, and I'm also now on the Java EE MVC expert group, which is one of the key topics we'll be talking about today. So that's all about me. Normally, if this were live, I would, ask about the audience, but since I can't see you guys, I'll just assume you're all like wonderful Java developers that have some idea about Java EE MVC and some idea about Polymer.
Actually, we have the best audience. I'll say that for.
Of course.
Yeah.
Yeah. Well, you're very prolific, and you got lots of people showing up, so I'm sure you've got a great audience. All right. So MVC is a actual new spec, a new part of Java EE, and it's slated for Java EE 8. It's JSR 371, and it's basically an action-based server-side framework, sort of like MVC, Spring MVC. So it's pretty similar to that. And basically, the idea, it sprang up because there was a survey. I don't know if anyone remembers, but I think it's about maybe a year and a half back. There was a Java EE survey. And basically it was like, okay, what do you want to change about Java EE? What do you want to see in Java EE? And one of the sort of resounding preferences that came out of the survey was we would like to see another a web framework alongside JSF that's part of Java EE that has more of the traditional action-based programming model as opposed to the component-based programming model that JSF has. So because of that, we started the MVC JSR. And the current release is EDR2, which means Early Draft Review. And that came out earlier last year, about the middle of last year, in time for Java 1. And the reference implementation is called ARK, excuse me. Of course, it pretty much only runs on Glassfish, although you can get it running on Tomcat if you try. And for those who don't know, the schedule for Java EE 8 is actually slipped. It was originally supposed to be out like the third quarter of this year. Now it's the first half of next year. And there were a couple reasons cited. If you do a search, you can find some articles on it. But they cited wanting to make sure they get everything right, but also I think there's been some constraints on the time of a lot of the Oracle people. So right now it's scheduled for late or first half of next year. So what you'll see today in regards in terms of Java EE MVC, may definitely change before this stuff is final. But there are working bits out there now you can play with that and do actually run, and you'll see that today.
And I think with many vendors, what they tend to do these days is release JSRs into their app servers before the full Java EE 8 is released, right? I mean, people don't tend to implement everything when the umbrella JSR gets released. Is that fair?
Yeah, and they sort of pick and choose, and I think some of them now just recently got Java E8 certified, E7 certified within the last year. So yeah, so they kind of add them over time. And what's good about MVC is that it's pretty lightweight. So I would expect this to be one of the ones that people just the vendors kind of just throw in there, pretty quickly. So.
Right.
All right, so one of the first questions is, well, what about JSF? You have Java EE, now you have two frameworks in there for web applications. And that's going to be the way it is moving forward. So it's not a replacement for JSF. If you like JSF, you like that way of doing things with the component model, it all works just fine. It's not going to go away. But for shops that don't use JSF or that are working or maybe have some older JSF and now want to do some stuff with a different front-end technology, you can use MVC. So if you look at a component-based framework, this image is courtesy of Ed Burns, who's the co-spec lead for JSF and Servlet. He's a great blog post you can look at called Why Another MVC. So the first thing to keep in mind is that JSF is an MVC framework. All of these frameworks are MVC, Model View Controller, in some way, and there's all these different variations of MVC. The idea of MVC today is different from the way it was when it first came out for Smalltalk. But the way that JSF does MVC is by having your controller, which is mostly what the JSF framework does. So it does a lot of the heavy lifting of your controller, deciding what page to go to, dealing with referencing different views, backing beans, all that kind of stuff, and it does a lot of stuff. Then you have your pages. Your pages use the expression language to talk to different beans, which are CDI or JSF managed beans or Spring or something like that, and talk to your model objects. So this is the way the JSF works. So you've got basically this large controller that tries to do a lot, which is great for some things and not great for other things. With an MVC style framework, or I should say an action-based framework, you have a topology more like this, where the framework doesn't do as much stuff. Basically, it just dispatches two controllers based on requests, and those controllers can then execute different actions, and those actions can go to different views, and those views usually will tie back. And in the case of MVC, they'll still do it via the expression language back to some sort of form bean, which can then talk to the model. So this is usually the more typical architecture that you see here. And the other thing to point out here is that a lot of the web frameworks have stuff built in for page navigation and things like that, which in single page applications isn't as common. Or is not common in a single page application. So there's nothing to keep you from using JAX-RS, for doing pure REST stuff or just returning JSON and things like that. And what you'll see is that it's very, very easy to mix and match JAX-RS and MVC even in the same class, which is very nice. All right, so as I said, it's built on top of JAX-RS. It's actually basically a lightweight set of annotations and features built on top of JAX-RS. So if you're familiar with that, it's very easy to use. The controllers must use CDI, so it's very sort of CDI-centric. If you're using Spring, you probably would just use Spring MVC anyways. So think of this as an option for doing stuff, to basically building an application in a Spring MVC style, but use the whole Java EE stack and not having to use another third-party framework just for doing a basic web application. Controllers can be in request scope. They can also be in other scopes as well, but usually they're in request scope. And you can handle errors inside your controller. So in JAX-RS, you actually get sort of a central error handler. So if there's like a problem with binding input values, you get or request values, I should say. You can get a global error handler and look at stuff there. But if you're processing a form post that's actually from a web page, you actually want a little more fine-grained control, and MVC provides that. Another nice thing about it is that you can bring your own template engine. So out of the box, it works with JSP. It also works with excuse me, with Facelets, which is the template engine that's part of JSF. You don't have to use JSF in order to use Facelets. You can just use Facelets with MVC, which I actually prefer. But you can use JSP, but you can also use other template engines. There's a pluggable template engine API, so you can actually plug in different ones, and there's several that are actually available currently. So you can use Timeleaf or Velocity or FreeMarker or whatever you want to. So that's one of the nice things about it. There's also built-in support for cross-site request forgery protection, support for encoding, so you can avoid cross-site scripting attacks. And that's about it. So I'm going to go through sort of the intro stuff, and then we'll go and look at some actual code. But there's really not a whole lot to MVC. It's just a very lightweight framework that you can use on top of JaxRS. And although I'm sure there will be some changes as we continue to refine the spec, I don't think there's going to be any drastic changes to that whole philosophy. So that's Spring MVC, Java EE MVC in a nutshell. But then you got to think about the UI, right? So if you're not using JSF, you don't have components that you can use that integrate with the backend automatically. So you got to pick some front end, right? So you could pick Angular, you could pick what's the other one that everybody uses? React, excuse me, or your own another framework as well. But if you're like me, you still would like some sort of encapsulation, right? So you like some sort of UI component way of doing things. You don't want to just manually write a whole bunch of a JavaScript code to wire everything together. So you want to pick some component, some way of doing things, some way of creating widgets and stuff for the front end. So if you think about it, UI components, they're pretty much everywhere on every web page, even if they're not actually specifically built using widgets, right? So even if it's a hand-coded JavaScript, it looks like a component on the page. So if you look at here, this is a picture of Dropbox. You can think of these things as all different components, right? So this is a sort of data list component, right? It has different columns that you can display. It has behavior built into it so that when you hover over something, it gets highlighted, and you can share different things. So the actual features that are available per row are being displayed here when you hover over. There is a toolbar. There's a search component. There's a drop-down list here. There's your quintessential breadcrumbs component here. And then there's also different menu buttons. Okay, so you can think of all of these things as components. And traditionally, when you build a web application today, you have to use a component, some way of building a component, right? So back in the day, or actually pretty much for the last 20 years, we've been building applications using some sort of UI components. So in the olden days I should say, but in the client-server days, you basically had things like Visual Basic, Delphi, Power Builder, etc. for building applications that gave you widgets to work with. Then we had ASP.NET, JSF, JavaFX, Swing. They all provide widgets to work with. So you got to have some sort of widgets to work with. With web applications, you end up with different component suites as well. So you could be using YUI, you could be using jQuery UI, Prime UI, Bootstrap, whatever, to get some cool widgets, or you could be using some Angular widgets as well, right? But basically, each one of these different frameworks have their own component model, right? If you want to mix and match them from different places, you may have issues, and each one kind of has a totally different way of doing things. So we build web components so that we can reuse functionality, and we have a lot more choices if the sum total of what we can use is greater than a particular ecosystem, right? So if we could actually have components that worked no matter which web framework you're using, we actually could do a lot more, and we could reuse more code across applications and have more choices within a single application. So if you take a look at this, no matter what component suite you're using for your web application on the front end, in the browser it's going to look something like this, right? If you look at the code, it's a whole bunch of HTML with divs and CSS, right? So you have a whole bunch of HTMLs with div and CSS, but the page doesn't tell you anything about the components, right? So if I say div, okay, ID equals browse sort, okay, that sort of tells me a little bit about it, but the HTML is really kind of dumb, right? It just knows about divs, spans, has a few primitives, sections now. It has basic input controls, but doesn't have anything like, data list or breadcrumb or anything like that. So the code doesn't actually match what's happening. So regardless of which component model you use, basically at the end of the day, it is translating the API that it's provided to you into divs with, in HTML and CSS and JavaScript. So that's all wonderful, but we like to work with abstractions, right? So we like to be able to say, well, instead of writing a whole bunch of divs and manually manipulating it with JavaScript and appending to the DOM, or repeating it in my template language, I really would rather just say, hey, here's a data table, here's my data, here are some properties that I want to throw on my data table, right? So we can get that with different component technologies, right? So this is an example of a prime faces data table, right, which is JSF, server side, but the concept is still the same, right? You basically declare something, you have some properties that you add, you bind it to some data, right? But at the end of the day, it renders HTML, JavaScript, and CSS, right? Same thing goes with client-side options. So here's Bootstrap. Doesn't look quite as nice in terms of the way that you represent things, but there is a certain way to do things. You give divs to certain classes and IDs, and you can use some JavaScript and wire things up and get things going. This is jQuery UI. Same sort of deal. You have to use certain IDs and certain structure, and then you can use JavaScript to basically turn that into a tab component, right? So, we have these sort of abstractions, but each one has a very sort of a different way of doing things, right? So the answer to this is to basically say, okay, well, we have all these different component models. Let's come up with one that sort of works that's actually part of the web platform, okay? So web components bring a native component model to HTML. So instead of having different frameworks with different component models, there is one component model, one interface that we can use that actually works inside of a browser and not just inside of framework X. So as an example, here is your quintessential modal dialog, right? Very straightforward. You could do this with a div and a button, or a link and a little bit of JavaScript, right? But you may want it to look a certain way under certain circumstances. You may want to add some additional behaviors, some additional features, and it would be great if you could just access it like this, right? So this is a Polymer dialog component, and that's what we just saw here, right? And you can see this is actually how you use it. Paper action dialog, backdrop. These are properties that you can set. Here's the content. Here's a button, a Polymer button, and excuse me. And you can basically use these attributes to tell it how to handle the button, how to integrate the button and the dialog. Okay, so here we basically have encapsulated some HTML, CSS, and JavaScript in a tag, right? But this tag is actually understood by the browser. So this is not a template language that we've created or a special framework that we wrote. This is actually something that works inside of a browser. So that's sort of the promise of web components. So basically, web components are a collection of HTML5 standards. There's a few different ones. The most important one is custom elements. And custom elements basically allows you to extend the native language of the web, HTML. So you basically can create your own element, like our example here, like this, paper action dialog, or Kito's fancy component, or whatever. So you can create an element, and then behind it you can put some actual code to do things, to append stuff to the DOM, to handle some different event handlers, etc., etc. So that's the number one spec. There's a couple more, or a few more. One is HTML templates, which gives you client-side templating. It's not quite as powerful as some of the client-side templating engines, but it does allow you to basically take a snippet of markup, or as much markup as you want, and then have the browser parse it, but not add it to the DOM until you're ready. So then, while it's in that state, you can append it wherever you want in the DOM, or you could interpolate it and do some expression evaluation or whatever you want as well before you add it to the DOM. And you can also add it to the DOM repeatedly, right? So there's a lot of stuff you can do there. There's also HTML imports, which allow you to import a whole bunch of, well, basically, you can think of it as a way to import another HTML document, okay? And that HTML document can have an HTML template, it can have JavaScript, it can have CSS, it can also have other imports in it. So essentially it allows you to pull in a whole bunch of dependencies without necessarily requiring them to be rendered on the page. There's another one, which is Shadow DOM, which I think has the best name of them all. And Shadow DOM basically provides encapsulation, usually in the context of custom elements. So essentially, with Shadow DOM, you can when you build your own custom element, you can have its child elements not be visible to the outside world. So the main benefit of that is encapsulation, so that when you have CSS, it doesn't leak all over your components. I'm sure most of you have run into a situation where you're trying to use some front-end framework or widget set like Bootstrap or something, and you use your own custom style sheet, and then it starts interacting with the styles of the components in a negative way. And then you got to work through all those issues. So the promise of Shadow DOM is that your CSS does not affect the CSS of the components unless you sort of opt in. So they can provide like an interface in terms of which properties that can be changed via CSS. So those are the core specs. Now, as is usually the case with HTML5, every browser doesn't support all these things. However, all the browser vendors are on board, and this stuff is showing up in pretty much every version of Chrome, in some versions of, or later versions of Firefox, and now we're actually seeing stuff being implemented in Safari, and Microsoft Edge is actually on board too with a couple of the specs. So it's not going to be supported in IE. IE is pretty much dead to the world in terms of development, fortunately. However, there are polyfills which provide the support for all of these things in older browsers going back to IE 10. And they're actually pretty performant. So you can actually do this stuff going back to IE 10. If you're stuck with IE 8 or IE 9, I think there may be some polyfills which do IE 9, certainly not IE 8. So that's the story. So I'm not going to do a demo of that yet. So in the wild, if you want to actually see some of this stuff in action, there are web component toolkits that basically make it easier for you to write your own web components. There's two main ones. One is Polymer, which has some really nice syntactic sugar for writing web components and some extra features for things like data binding. There's also Xtag, which is more lightweight, but has some of the same features. Polymer is sponsored by Google. Xtag is now sponsored by Microsoft. It was originally written through Mozilla. And there's also some component suites out there as well that are already using web component technology. All right, and if you want to just sort of do a quick search to see what components are out there, you can go to customelements.io, and you can say, okay, well, I want to find a dialog component. Yep, and look, there's all these different web components that are actually dialogues. And all these are actually on GitHub, and I can go and, grab some from there. Okay, so let's say I want a paper color picker. I can see what it looks like, and then I can see some documentation. It tells me, okay, so this is actually a web component that uses the Polymer APIs, but in terms of usage, it's just a web component. And this is how I can use it. I could go and look at a demo if I wanted to, which would show me how lovely and beautiful all the colors were. Okay, so it's a good place to go to get an idea about what's out there. All right, so just a very quick overview of Polymer. There's a few different parts. One is custom elements, which is basically a set of off-the-shelf widgets you can use. There's also the library, which provides sort of the syntactic sugar for building web components on top of the core specs, which are the web component primitives themselves. And as I said before, those primitives are either implemented directly by the browser or via polyfills right now. All right, so these are some of the features of Polymer. I won't get into too many of them, but you'll see a little bit of an idea about how they work. But basically, these are just features that make it really easy to build web components. You get some data binding, you get a simpler programming model, and this is basically what you generally see with standards, right? The standards have a very specific sort of either complex or simple API. That's what gets built into the actual browser or the product. And then people come up with ways to make it even better. So Polymer is doing that. Xtag is doing that. And then what will happen is after the first round of specs are done, they'll probably add some of the features from Polymer and Xtag that work into the spec. All right. So Polymer is actually developed by Google. Of course, they do take contributions, but there is a team at Google that works on it. Google claims it's used by over 300 different projects. I'm sure not all, and I don't think most of them are public, but the biggest one they mentioned though is gaming.youtube.com. So if you're a gamer, which I am not, but you can go to the site, and you can, it looks like any other site. But what's interesting about it is if you actually look at the HTML, you can see that these are actual web components. So this is a web component they've written. Somewhere in here there is some, there's actually some straight up Polymer components too. They've written a lot of custom web components for this. So all this is written using Polymer and web components. So actually the page reads a lot better, right? Because you can see, oh, this is a home page. This is a video carousel. This is a toolbar. It's not a whole bunch of divs with maybe a class that tells me what it is or an ID. And the beauty of this is that the API that you work with is really just by grabbing the element and calling it via JavaScript if there's something you need to do like start or stop or something like that. So I imagine that site gets a decent amount of traffic, so it's a good indicator that you can actually use these things in prime time. They claim there's only over 150,000 public-facing web pages using Polymer. I have no idea where they get that number, and I have no idea how many pages are considered. Like if you have a site, how many pages they count for that. I'm not sure. All right, they're also using it in parts of Chrome.
So talking about numbers then, Kito, I've got a question in from Suni about comparing some of the different frameworks that people use and things like that. Would you say what would you say is a popular combination or a popular thing that people would use if you were to compare something like JSF to more JavaScript style environments like Angular or React?
Okay, so I don't quite get the question. I'm sorry. So are you saying so what's a popular combination for using with web components or Polymer?
What's a popular combination or just popular frameworks in general that people tend to use for their components, for writing UI?
Okay, so if you weren't using web components, yeah, I would say those are good examples. JSF, or on the client side, Angular is very popular. React, you can write components in. So those Angular and React tend to be more frameworky, although I think React focuses more on the sort of front end side of things than Angular. Angular sort of does everything. But then jQuery UI is a good example. It's been around a long time. Or Kito UI is another one. There's YUI is old, very old. No one uses that much anymore. So it's things like that. People, if you just wanted widgets themselves, with React and Angular, you're tied into that particular ecosystem with those widgets.
Okay. Awesome.
Okay.
Thank you.
Welcome. All right. So this is an example of what it looks like to build a Polymer component. You can basically this is sort of the start of the document. This is the name of the element that you're building. This is using HTML5 templates to specify the CSS that you want to use, the actual markup that goes in the component, and then this is where the content is injected. So if there's any elements which are placed inside of this when it's used inside of a page, they would be put here. This is Polymer's own built-in data binding. This is not part of the spec. But basically, inside of the component, there is a property called author. So this data binding is binding against that particular property. So this is the component itself. These are the properties that it has. And then it has different lifecycle functions that you can use to be notified when it's ready, attached, etc. And then you can add your own functions to it. So the way you'd use this is by basically just using a seed element as just like an HTML tag, right? And you can add attributes like type or value to it. So this is just an example of how you might write a Polymer component. All right, so we'll mention there's also, on top of the actual library of Polymer, there are a whole bunch of components that are just ready-to-use components. So you can either use Polymer to build your own components, just use off-the-shelf components, or you can use them all together. And Polymer has enough stuff in it where you can actually build an application with just Polymer, or you could try and use it with another framework. A popular question is, can I use it with Angular? And the question is maybe. I've heard mixed stories, so I'm not 100% sure. I'd say more likely to use it with Angular 2 than Angular 1, but I'm not sure. So I'm not going to go too into this, but I will say if you want to see what the Polymer components are like, you can go to the element catalog, which has all these different areas. And there's really nice sort of demos for all the different components, dialogues, headers, panels, menus, ripples, tabs, etc. For each one, you can find the docs. And you can also look at a demo, which gives you an idea of how it works. Okay. And there's stuff in there not just for visual components like I'm talking about here, but also you can use web components to wrap APIs. So for example, if you want to throw a Google Map on your page, you could use the Google Map component. And this is very similar to what we've done with JSF components in the past. You just provide the attributes that you want, and then it handles all the integration with all the Google APIs. And this is an example of actually using that element. So you just get it like any other element on the page, and then you can add event listeners and change properties stuff. So there's a lot of stuff in here. All right. I think we're about ready for a quick demo. All right. So now we'll get to the actual more interesting part. So how does this stuff all fit together, right? Let's say we had wanted to make a very simple application, right? If this is a to-do application, I thought I would copy everybody else and make a to-do app. So let's say we wanted to create a to-do application, and want to log in. And when you log in, you can go and add some tasks, right? So let's say I want to add a new task, say hello to the, all right. So I've added my task, and then I can mark it as done. Hello to the virtual Java users group. So now my task is done. And then I can go and I can delete tasks. Then if I were to log in as a different person, I could see those tasks, right? Then I can add one. All right, then if I refresh, I get my new task, which I will now check off. And then over here, I should see my new task checked. So very powerful application, right? And then of course, we've got another page that just has an about. Okay. So this is our app. So in order to do this, basically, oops, wrong screen. Okay. In order to do it with Java EE MVC, you basically would create a normal web application. So you see over here, I have sort of a standard web app. I have my web.xml. I have beans.xml so because it's a CDI application. Faces config is only here to configure a resource bundle to use inside of a facelet page. And remember, we're not actually using JSF. It's just here for the facelet page. the web XML, the only thing it has is the welcome page and then also the Faces servlet, which is just for facelets. If you're using JSP or another template engine, you wouldn't need this either. Okay, so that's basically all you need for that part. Then, because this is a JavaServer application, you can have an application class, and the application class is where you can specify properties and some other sort of global things like the actual path for all of the resource requests. Here I'm specifying one parameter, which is to make CSRF protection explicit, so that it only will do CSRF protection if I explicitly tell it to do on my controller method. This had to be done. I was using implicit, but there was a bug in the reference implementation that made that not possible. So you can also turn it off completely if you want to. Then in terms of the actual code, we can look at one thing first. So we'll look at this authentication controller class. Okay. And let me just collapse this stuff, make it a little simpler. Okay. So this is a pretty standard Java class. Doesn't have to subclass anything. This is a JavaServer annotation. This is an annotation to specify it's an MVC controller. MVC also adds a new scope called redirect scope, which just puts something in scope, just for a redirect. So basically, if we do a redirect and then reference that same object, it'll be there. It's usually not used for controllers, so you might more often use it on some sort of object, CDI, a model object you're using, but just wanted you to be aware that that's a new scope that's been added. We're using injection here, normal CDI injection, and add our user service, add the service, the session request. Models is a special Java EE MVC annotation, or special object. So anything you put inside of models, which is basically a glorified map, shows up in the actual page, or basically it shows up in the request as a request scoped attribute that you can use in the next page. So you'll see that in a minute. This is just my custom user object. Binding result is another MVC feature which allows you to essentially handle any errors that occur when the input or query or form parameters are being bound to your model. So you can think of this as a way to get a handle on validation or conversion errors. Messages is a proposed feature of MVC that basically just gives you an object that has a collection of messages you can display. So when you get binding errors, you can turn them into messages and display them. This is not actually part of the spec yet, but most likely will be. So here is our login method. Okay. And basically what it's doing is it's just taking two form parameters that are being sent in. It's talking to the service, and it's if the user is actually present, it is going to set an attribute on our session, because since this is MVC and not JavaServer, we can throw stuff in the session. And then it's going to do a redirect to the to-do page. Okay, so these methods can return strings. They can also return void. If they return void, they need to use a @view annotation to specify the page that is displayed. But they can also just return a string. Obviously, redirect means it's going to do a redirect, but it could just return this value, and you see the extension is .xhtml because this is a facelets page. So basically, the template engine is chosen based on the extension by default. But I could also have returned this. I could have returned this instead, right? And this is the JavaServer response object. So this gives you total control over the response. You can still return that just as you would in JavaServer, although clearly you would want to actually, do a redirect or something as opposed to return JSON in this particular case, because this is a controller method. You also can return a new class called a viewable. And a viewable is another MVC object that gives you sort of additional details, so you can use it to specify the name of the page, whether or not you're doing a redirect, but also for things like the template engine, etc. So basically, when you return a string, MVC basically creates a viewable out of it automatically. So these are different ways you can return the value. So in this example here, when we go to this, whoops, all right, where's the actual right page? There it is. Okay. When we go to the login page, we're hitting this login method, right? Well, I didn't actually mean to have a breakpoint there, but there it is. Okay, so this is one way to do things. Another thing you can do is you can use bean validation and an actual sort of form object. So in this scenario, we have the bean validation set up. We have a login form object. That login form has bean validation annotations to specify the parameters or the constraints for the particular properties. Also uses that form param annotation to say it's a user ID, etc. Okay. So this allows us to actually do some validation here, and by putting it inside of the parameter list for this method, we actually get the validation to occur before it hits our code. This here will go through the results of that validation. If there's any failures, it'll get the value, and then it adds the value to this messages object. Okay, so this is basically getting any validation errors. This code is pretty much the same. It's going to go and redo a redirect if necessary. Okay. So if we were to go look at our login page, which is actually a JSP page, looks something like this. This code is actually was derived from the Polymer starter kit, which is a freely available little kit that's great for starting a Polymer application. Gives you all the stuff you need. So a lot of the stuff at the top is really provided by that kit. This sort of viewport stuff, theme colors, the Android meta tags, etc. All that's just there, and it seems like a good thing to have, so I left it there. But you will notice here that I'm using an actual normal resource bundle, right? So we're using JSP, so I can just use a resource bundle to get these values. So if I go here, these are all my strings. So if I want to do internationalization in a standard Java way, it's pretty easy to do. There's also this MVC implicit parameter, or I'm sorry, implicit variable for the expression language, which I can query for things like the context path. So I can make sure this is always going to be relative to the context path of the application. And then down here, there's some interesting stuff. This is the Web Components polyfill. And what's good about this is that if your browser supports stuff natively, it doesn't actually use those features. So Chrome supports most of this stuff natively, so Chrome doesn't use it all as much as like IE would, for example. But down here, this is that HTML import. So you see, instead of saying rel equals style sheet, it says rel equals import. So we're importing this elements.html file, which has all of the custom elements that we want to import, which are the web components. So basically, you can see we've got all of these different paper components that we're importing. There's layout, panel, menu, etc. Okay. And then down here, there's also a JavaScript router, which is just for the second part of the application. And there's a theme. And then there's also this MVC tasks, which is actually a custom web component just for this application, which we'll talk about in a minute. So we're importing all that. And so an HTML import can have all this stuff, but then if you look at any one of these files, they can be different things, right? So if I look at this one, writing.html, writing.html is a file with a script element in it, right? So HTML imports have a lot of flexibility. I will admit, though, it's actually one of the more contested specs, but that's a story for another day. All right, so then in the page, I'm using a special template tag so that I can put data binding, the Polymer style data binding inside of this page. If I wasn't going to do that, I wouldn't have to put this tag in here. I could just use these components without it. So these are the Polymer components. This is a normal JSTL segment for going through the list of messages. So if there are any messages, I can go through the list and display them, just normal HTML. You may have noticed here, and actually I'll go back and show this. So there's a couple different errors that can occur, right? So one of them is this, right? So if I say test, put in the wrong password, it says wrong username or password, right? So what's happening here is the controller is putting the value login error in the models object, right? And then that models object is basically dumping that value out so that I can access it directly in the page as an expression. So login error is true, so I'm displaying the login error message. So that's why you're seeing that error message there, the complaints about the user not being a valid not having a valid password. If there were validation errors, I would get the actual values here. So if I go back here, whoops, I always do this, so let's go to this wrong screen here. All right, so if I do test like that, it's about the username and password, right? But in this page, right now I'm posting back to login no validation, which is the first method I showed you. If I change this to be login validation, which is the path that's specified here, I'll now get the actual server-side validation. Make sure that's there we go. So now it's complaining about the validation because it hasn't even because the validation occurs before it even gets to checking to see if the valid user. Okay, and that's happening with this CIF and the C for each here. Okay. So inside of the form, I have the actual input controls. There's two input controls that are the paper input components. So they give you the kind of cute visualizations and everything. And you see I've bound to user ID, right, as the value so that when the error message comes back, you actually see the value you put in for the user ID, but of course not the password. And the reason that's there is because I also put user ID in the models object as well. Okay. But remember, since this is normal expression language, you could very easily reference any CDI object. So it doesn't have to be in the models object. It could be something in any scope, any CDI scope, request session, conversation, whatever. Okay, so so this is the input control. This is the button. There is a little nuance with the paper input controls, which is that they kind of assume you're doing AJAX. They don't actually do a normal form post. So if you want to do that, you have to write some JavaScript to do the validation. So this little JavaScript here is actually doing the validation on those components, and that's useful because in addition to just looking cute, these components have client-side validation as well. Right, so remember how to undo the comments in here. I totally forgot how to do this.
I guess it would be Command / in the.
Yeah, that's what it is. I don't know why I just totally blanked on that. Thank you. All right. So here we're actually using the actual validation that the components provide. So you can specify an error message, which we're getting from our resource bundle. You can specify a pattern, label, you can say it's required, etc. So we can do all this on the client side. And because we're not using the special Polymer form, we have to do the validation ourselves. But this is a good example of actually using the client side, the actual API for the web components, right? So they have an API, and one of the methods is validate. And so in order to execute it, we just have to basically grab the element from the DOM and then execute its API. Okay, and then we're putting these fields in the form to submit back to our page. To our controller, excuse me. So that's the basic idea. So let's go back here, do a refresh. Let's see, we do TT. Okay, now we get our Polymer validation first, right? And so we still have a server-side validation, but we also have the Polymer validation as well. Okay. So that's sort of the quick overview. It'll last like, 3 minutes. We'll look at the rest of the application. When you go back, when you log into the application, you see all these different cards, right? One for each task. And then you also see the About page, right? So that's all handled by the todo.xhtml page. So todo looks like this. And IntelliJ is complaining because it's expecting these to be normal HTML elements, and they're not. There are different plugins. There's actually a Polymer plugin that I'm using here, but it's not completely up to date, so it doesn't understand all these elements. But if you're using something like Sublime Text, there's a more up-to-date plugin you can use. So there's a few things here. There's all the stuff we saw before. There is this notion of shared styles, which is a Polymer-specific construct. Basically, it's a way that you can use styles that Polymer can interpret and integrate with their sort of extra features for CSS. Okay, so again, we use the template is part here so that we can integrate with the Polymer's data binding. We have this drawer panel, which is sort of the main container. There's a toolbar. There is the menu that has the home and about links. Okay. There is a header panel here and some toolbar icons that go in here. And this is the main part. Iron Pages is a special component that allows you to sort of switch between different pages. And so each of these pages are sort of defined by sections. So this is a single page part of the application. So this navigation here is just defined by switching different pages which are inside of the Iron Pages component. So this one's pretty straightforward. Paper material just sort of decorates sort of a decorated div, right? But this is kind of interesting. So here's a paper card, but inside of it is this MVC tasks component. And MVC tasks is actually a custom component written for this application, and it has a couple of properties. One is the endpoint, which is the actual JAX-RS or any RESTful URL that you would use to get the data back, and the user ID to use. So this one looks like this. So it has a couple imports. It uses Polymer and Iron Ajax component. It has its own styling, which is local to this component. It actually has this Iron Ajax component, which is actually used to do all the Ajax stuff. So this is sort of an important thing, is that, you know, even though custom components are usually thought of as, you know, sort of front-end UI things, that can also be just something with functionality. So these actually do provide the ability to go back to that JSON endpoint and get the data back and throw it into an object. So this is actually what we're using for all the Ajax updates here. This is the new task button part. This is the list of different tasks, and this is sort of doing a repeat. So you can think of this as UI repeat in JSF terms or C for each in JSTL terms. And then this is the actual component. It has those three properties. It has places to handle these different handlers, or the different event handlers, handle task selection, new task, etc. And that's pretty much it. There's not a lot going on. All the work of translating JSON into objects is pretty much straightforward. Okay.
So, Kito, we've got a question in IRC that's being +1'd quite a few times.
Okay.
And I think the question was originally from Zakaria, but Bartek and KK and others have +1'd, Aslan as well. The question is, what is the key differences between Java MVC and Spring MVC? So why would people choose Java MVC over Spring MVC?
Yeah, I think that's a good question. I think you know, the idea is that basically Java EE tries to be an all-inclusive platform. You know, whether or not it is you know, depends on who you're talking to, right? So basically, for just about everything, there's some Java EE version. It may not be the best version of something, but there's some way to do it in Java EE without requiring Spring. So I think the consensus was that there was sort of a gap missing, so that, you know, you could use Java EE without having to use Spring to fill in some gap. I think so. I think that's really the main reason. If you're already Spring Shop using Spring, I wouldn't really see why you would switch unless you were starting to do more projects using CDI and some other Java EE features.
So
But I think,
perhaps if people are using the Spring framework but actually consider it to be maybe too big and just want to use something that the container might offer, this might be an option. Or perhaps if people are doing a greenfield project and just want to use a kind of MVC, this might be an option. But if you're using much more of the Spring ecosystem, it may be worth sticking with that.
yeah, that's what I would say. It's kind of like, if you just want to add a little bit of MVC to your application or a little bit of basic routing and some basic controller functionality, you shouldn't have to bring in all of Spring to do that.
Right.
But I don't really see why you would switch if you've already got a huge investment in Spring MVC. I don't really see it. I think the only other piece it's missing is the authentication stuff, like the Spring Security. There's still no good answer for that as part of Java EE, as far as I'm concerned. So we're about at the end, but this should give you the basic idea. The one other real quick thing I'll mention is that if you look at the controller, the task controller, just like in Spring MVC, you can mix and match the JavaServer stuff, right? So this controller is doing mostly JavaServer. This is just normal JavaServer requests and responses that are just basically returning stuff to and from JSON. You can though mix and match, so there's a controller method in here as well. So if I wanted to go directly to the list of tasks, I can do it like this.
Boom. That's unexpected. Simon, can you hear me?
I can hear you. Yeah, it looks like we just lost Kito. So hopefully Kito will rejoin us.
I think I know what happens. He probably just clicked Command Q instead of Command W.
Isn't that frustrating that Q and W? They chose Q and W, and Q is so close to W.
Yeah, that's like close one page versus close everything.
Okay, so while everyone is looking at us rather than Kito, if anyone does have any final questions, do feel free to pop them in the IRC. And we'll see if Kito can rejoin us, but I think we were pretty much at the end anyway on this call. What do you think, Oleg? Would you do you think Java MVC is a worthwhile alternative to Spring MVC?
Well, to be honest, it's not. Currently it's not really an alternative as far as I understand, right? So this is the proposal. The specific JSR is Java specification request. So this is the standard that is going to have some reference implementation, which is very similar to Spring MVC currently, its current form.
Hello.
Hello, Kito.
Hey, how much of that did you miss? Because I was rambling for a while.
We've only missed you for about the last 30 seconds to a minute.
Okay, because Google Hangout said my computer went to sleep, which is kind of not logical.
Oh, wow.
All right. Well, I guess, did I finish? Did you see the part where I finished the talk?
I think we probably we only just lost you, so I'd probably say almost.
All right. All I was saying was that if you wanted to find the code, you can go to if you type in Kito99 on GitHub or go to noesis.io, you can find it. You can find examples and the slides.
Well, that's great timing actually, because that was one of the questions that we just had asked. So yeah, I see Kito99 on GitHub, so I'll paste that into IRC.
All right.
Right now. We have another question on IRC, I think. Oleg, did you say you saw one?
Yeah, I see a good question from Dr. Horrible.
Great name.
Say, why would I choose Web Components over React.js, which also provides components?
Um, so the answer to that is it's the whole standard concept, right? And as someone who's worked with standard technologies for a long time, I'm into that stuff. So my general answer is that you choose React, you're stuck in the React world. You're limited to whatever React provides. You choose Web Components, you're not beholden to any particular framework. Or any particular way of doing things, and you're using actual web standards, which are going to be baked in all the browsers. So I think there's actually a much better longer-term proposition. React is very cool now. Will it be around in 10 years? I don't know. But web components actually will be around, and they'll be in the browser in 10 years. Like, they just will. Now, whether or not, if for some reason they don't take off and people have moved on, maybe nobody will use them, but they'll be in the browsers. So it's sort of, I've actually been doing JSF stuff for over like a decade, which is actually quite amazing. And the reason, obviously there are certain aspects of the technology which made it last that long, but also, it's a standard. People know if the company puts all this money into a project, they actually have some assurance that it's going to be there in a few years. So.
Okay, a couple more questions coming in. One from Bartek. Would you recommend using Polymer on production? So I guess, yeah, in fact, he goes on to say, do you consider it as production ready?
Yeah, I do. Actually, this year, I think it was Google I/O. They released 1.0. Before that, they were at sort of a proof of concept sort of phase. So which is like the 0.5 era version, which actually I'm actually working on a project that's actually using 0.05 in production. But 0.1, what they did was, 1.0, what they did was they basically tried to make it as fast as possible and made some trade-offs for speed and to make it production ready.
Mm-hmm.
So, and to me, the best example of that, the fact that U2 Gaming, I have no idea how much traffic this site gets, but it gets probably more than most of the applications I worked on. I'm just guessing, since it's a YouTube Google site. So to me, that's a good example of the scale that you can handle with it. And Google believes it's production ready. So.
And in terms of usage, was that 150,000 pages? Was that for Polymer? I can't remember which.
So that was just Polymer.
That was just Polymer.
Yeah. So we don't really know. We don't have any stats on just regular web components in general.
Right. Okay. We've got a question from Pioneer in IRC. Do you have experience writing web components in any other languages other than JavaScript? So using Polymer GWT or anything like that? Do you feel it's usable or mature?
That's a good question. Actually, so with GWT, all right. If you go to GWT, you look down here under, where is it? Docs. Is it tutorials? Here we go. GWT and Polymer. Woohoo! And this is largely because Vaadin, which has been doing Java stuff for a long time, uses GWT, and they started doing Polymer stuff. So they have a bridge. So basically, what they're doing is they wrote some really powerful Vaadin components, which are built on top of GWT, and they also are exposing them as web components. So they built a really good integration layer between the two. Mm-hmm. Also, it is possible to use another language like TypeScript or something else, so anything that can cross-compile to JavaScript you can use. And I've seen some examples, and I'm interested in TypeScript because I like type safety. But any language that you can translate into JavaScript or transcompile into JavaScript you can use.
And what was the link for that? Sorry, I think I'm not sure if you thought you were showing your screen then.
If you could just go to the gwtproject.org, look at the documentation, you'll find it.
Okay, so GWT, is that gwt.org?
gwtproject.org.
Okay. And let's see. I think we're pretty much done with the questions. Okay. Actually, there was one question from Arslan about the difference between Polymer and AngularJS, but others I think answered that in the in IRC saying AngularJS is a full stack framework,
Right.
whereas Polymer is just a component.
Right. Although what I find fascinating is, and that's always been Polymer's line all along, is that we are a library. We're not a framework, right? But they seem providing more and more stuff to build applications without anything else, which I think is fascinating. Because if you look at the starter kit, which basically that to-do application just uses the same shell the starter kit comes with. If you're not doing anything too complicated, you could just use Polymer and its components like the Iron AJAS component. But yeah, if you have a real production, not production, but enterprise scale application, you're going to need more than just the Polymer components.
Okay. So I think I've just added your Twitter handle into IRC, so there's a link there if anyone wants to follow Kito. Feel free. And Oleg's just added mine in as well. Thank you, Oleg. I'll do yours in a second, so we're complete circle there. So yeah, thank you very, very much, Kito, for the session. Really interesting session. And again, thanks for joining us on the virtual jog. We've tried to make it happen over a number of months now, actually. But
yes, it's been a long time coming.
Yeah,
so I appreciate you having me on.
Oh, it's our pleasure. Thank you very, very much. And for others on wondering what the next session is going to be, because there's actually nothing on our meetups page right now. I'm being a bit slow for February, but we do have sessions. We have coming up in JFocus. We have a session interestingly on Vardin by some of the guys live. We also have another DevOps for Kids style session, which is going to be led by Arun and another DevOps for Kids speaker, and that's going to be around squishy circuits. So I'll put that out. So it's actually going to be on a Saturday. So do encourage your children to watch that with us. And it's actually going to be a nice interactive one, so people will be able to actually create their own circuit DOE, conductive DOE, and create their own circuits. That's going to be great fun. Wow. And we do have some other sessions as well, hopefully in February, which we're working on. So don't be afraid that there are no sessions up. There will be some. There will be some soon. I do work a number of months in ahead. It's just a case of putting them up gradually. So yeah, thank you very much, Kito, for an amazing session. That session will be written up by Oleg and available on Rebel Labs, as well as a bunch of links. And Kito, please do send us some any links that you'd like people to go to for more information, and we can make them available.
Okay.
And if you hang on, we'll on the Hangout, we'll do an interview straight after for Rebel Labs, and we'll make that available as well.
All right. Thank you, everyone.
Thank you very much, and see you all next time.
Bye.
Bye.